Welcome to my pre-algebra class. We're on chapter 12, section 4, and we're going to be working with independent and dependent events. Independent events are events that do not affect each other. So the probability of event A happening and then B, they don't affect each other, so we can multiply the two events together. The bag, for example, bag contains 3 red, 5 white, and 4 blue marbles. 2 marbles are drawn at random with replacement. You put them back in. So that would be independent. So the probability of getting white, there are 5 white out of a total of 12. And then red, there are 3 red out of a total of 12. So I could cancel, and my answer is 5/48. And dependent events do affect one another. So if I did not replace the marbles, then that's going to change my probability. So the probability of getting white the first time is 5 out of 12. However, I don't put the white back. There's 3 red. However, there's 1 less marble. It's 3/11. So cancel, and this time my probability is 5/44. And that's basically what you're going to be doing on your assignment. So you need to get your paper headed and turn to 554. And problem numbers 1 through 6. A drawer contains 10 blue, 15 white, and 5 black socks. 2 are selected at random with replacement. So this is independent. Find each probability. So number 2, the probability of white, then another white. They said there were 15 white socks, and a total, there were 15 white, 5 black, that's 20, plus 10 blue, that's a total of 30 socks altogether. So we put it back, and there's 15 again for the second time. Cancel. So our probability is 1/4. Problem number 4. The probability of both blue followed by blue. There were a total of 10 blue socks out of 30 socks. We put it back, and there's still 10 blue out of 30. Cancel. Get 1 and 3, so our answer is 1 times 1 is 1, and 3 times 3 is 9. So our probability is 1/9. Number 6, the probability of not blue and a white. Well, there are 10 blue socks, so there must be 20 out of the 30 that are not. So 20 out of 30. We put that sock back. And white, there were 15 white out of 30. Cancel. 2. 10 goes in there twice, and 3. 15 goes once and twice, and we could also cancel these 2's. So the probability is 1/3. Problems 7 through 10, 2 cards are drawn at random with replacement. Find each probability. You have the cards spelling out mathematical. So number 8, the probability that you don't have an M and then an A. And you put the cards back. So not M, there's a total of 12 cards. And there are 2 M's, so not M, there would be 10 that are not M. And the probability of A, there are 3 A's out of 12. And we put the cards back. Cancel. 2 goes into 10/5 and into 12/6. We could also, so it's going to be 5/24. Number 10, the probability that you pick a vowel and then another vowel, and we're putting the cards back. The vowels are A, E, there are 3 A's, an E, 4, and an I, 5. So it's 5 out of 12. And another vowel, 5 out of 12. No canceling, so that comes 25/144. Problem number 12, we're drawing 2 cards without replacement, so this is dependent. Probability of drawing an A, then another A. there are 1, 2, 3 A's. So the first time we draw, we have 3 out of 12. We don't put the cards back, and we drew A, so there's only 2 A's left and 11 cards left. Cancel, 2 goes into 12, 6, so we could cancel the 3 and the 6. So we ended up with 1 times 1 over 2 times 11, 22. So our probability is 1/22. Number 14, the probability of drawing an E and then a T without replacement. There is only 1 E, so that's 1 out of 12, and there's 2 T's. 2 out of, since we did draw an E, there's 2 T's, but we did not replace the E, so there's 11 cards. Cancel, 2 goes into 2 once, and then 12, 6. Our answer is 166. Problem number 16. The probability that you draw a card that's a vowel, don't replace it, and then you draw an M. A vowel, A, E, A, 3, 4, 5. There are 5 vowels out of 12, and M is not a vowel, so there's 2 M's out of 11 cards, since we didn't replace the vowel. So 2 goes into 2 once, into 12, 6, and we get 566. 17 and 18, a number cube is rolled 3 times in a row. Find each probability. So probability of an odd, and an even. And these are independent. Each roll, you still have those 6 numbers. There are 3 odd on a die out of 6, 3 odd on a die again out of 6, and 3 even on a die out of 6. So that's 1/2 times 1/2 times 1/2, which is 1/8. Problem number 20. We have a drawer containing 10 white socks, 6 blue. Kayla reaches in the drawer without looking and selects 2 socks, so that's without replacement. So this is dependent. 20, the probability that he selects a blue and then a white. There are 6 blue, and there's a total of 16 socks to start with, but he doesn't put the blue back. So now there are still 10 white, but there's only 15 socks left. So 5 goes in there 2, and there are 3. 3 goes into 6, 2, and 2 goes into 16, 8, and 2 goes into 2 once, and an 8, 4. So it comes out 1/4. 22, we have a bucket containing 10 yellow, 8 white, and 2 orange tennis balls. Without looking, Trina selects 3 tennis balls. And she selects 3, so that means she doesn't put them back. So that's dependent. So the probability, 22, that she has a yellow, and a yellow. So the probability that she draws a yellow the first time, there are 10 out of total 10 plus 8 plus 2, 20 tennis balls. She didn't put that one back, so there's only 9 yellow left and 19 balls left. And then she didn't put that one back, so there's 8 yellow and 18 balls left. So if we cancel, we get 1 and 2. 9 goes into 18, 2. And we could cancel with the 8 making 4. So it's going to be 4 over... Whoops, I forgot one more canceling. So we could cancel the 2 and the 4. So it's going to be 2/19. Problem number 24. She selects a ball and replaces it. Then she selects two more without replacing it. So the first part is independent, second part is dependent. So the probability that she draws the yellow the first time, then an orange, then a yellow. So she drew a yellow, and there are 10 yellows out of 20, and she put it back. So when she tries to draw the orange, there are 2 orange, but there's still 20 balls. And she put the yellow one back, so there are still 10 yellow, but now she didn't put that orange back, so there are 19 balls left. So canceling 1 2. The 2's cancel out. The 10 with the 20. And it's going to be 1 over 38. 2 times 19 is 38. The next event, 6 boys and 4 girls are finalists in a contest. All their names are placed in a hat and 3 names are drawn at random. Then prizes are awarded in the order the names are drawn. Find each probability. So the names are not going to be replaced. The probability that it's a boy, followed by a boy, followed by a boy. There are 6 boys, and there's a total of 10 people. Okay, so we drew a boy's name out, and we're not putting it back. So there are 5 boys left and 9. And then there are 4 boys left and then 8. So we can cancel the 5 and the 10 and we get 2. Cancel the 4 and the 8, we get 2. 2 goes into 6, 3, and the 3 cancels with the 9, 3. So it comes out 1 over 2 times 3, which is 6. Problem 28, the probability that we draw a girl's name, then a boy's name, then a girl's name. We draw a girl's name, there were 4 girls out of 10. We don't put it back. There's 6 boys, but only 9 names left. And we don't put that one back. There were 4 to start with, and we did put the girl's name back, so there's 3 girls, and then there are 8 names left. So canceling, 4 goes into 4 once and 8 twice. 3 goes into 9, 3. 3 goes into 6, 2. You can cancel the 2's out, so it's going to be 1/10. Problem number 30 and 32, the combination for a school locker consists of 3 one-digit numbers. For example, 059, 341 are possible locker numbers combinations. In exercises 29 to 32, the digits can repeat. If combinations are randomly chosen, find each probability. So probability that you will have a 4, 3, 9 is your combination. So there is 1, 4 out of 10 possible numbers, 1, 3 out of 10 possible numbers, and 1, 9 out of 10 possible numbers. And you can reuse them. So that's 1 over 1,000 is your probability of having that locker number. And 32, all the digits are the same. So probably the same, same, same. So the probability for your first number, you have 10. You can choose any of the numbers, so there's 10 possibilities out of 10. You get to reuse them, but they all have to be the same as whatever you picked here, so you only have one choice. And the same with the third number. It's already determined. So it's 10 over 1,000, which is 1 over 100. That concludes the evens. Be sure and check the back of the